Hi, Gophers.
Hello.
We are
Uh,
live for I think this is our first ever Pacific Northwest Go virtual meetup.
yep.
Official,
We
officially
had a
called.
we had a trial run last month, and it was cool. And we're trying to bring some normality to a very unnormal time.
Yeah.
Um,
So let's see. We've got two talks today. And Logan, you have some slides. Do you want to
mhm.
share screen and get going with the slides?
Sure.
Cool.
All right. So yeah, welcome to PNW Go, Seattle, Portland, and it sounds like we already got some folks from like New Zealand, Canada, uh, so a little bit further outside the Pacific Northwest. Got a bit of an echo still. So just bear with us. We're just kind of like feeling it out, see how things go. Um, Again, I appreciate you all like joining in. Trying to do like a normal talk night, distributed, not really sure what to expect. So try to adjust expectations and we're just gonna roll with it. Um, so a couple things we wanted to go over, just kind of like some administrivia type things. There we go. Okay. So since this is the internet, we kind of wanted to call out that we've got a code of conduct that we follow. It's the Go Community Code of Conduct. Talk about some of the sponsors we've got that are kind of making this possible. A couple of pretty excellent talks, and then at the end we're gonna raffle off a couple of JetBrains GoLand IDEs for folks that are interested. The actual logistics of that to be determined, but we'll give it a go. We'll figure it out. So with that being said, this is the Go Community Code of Conduct. So the TLDR is just be excellent to each other, just be nice, be respectful. It's a weird time in general, so just try to be nice. Just keep the chat kind of chill. Everyone's just kind of working through it. There might be some technical difficulties. Um, so yeah, just have fun this evening, but try to adhere to the community code of conduct. And our sponsors, Microsoft is providing us the Crowdcast license, so that's pretty much enabling us to actually meet like this right now. JetBrains is giving us the couple licenses to raffle away, and Google is providing the Meetup account. So they're all kind of letting us letting this happen. So really appreciate them doing what they can to make that happen. And that's it for the administrivia. If you want to give a talk after you watch Sean and Evan give their talks this evening, so maybe like next month, just shoot any of us a message. You probably have talked to Meg or Morgan or Vanessa if you're up in Seattle. Shoot them a message. We're all kind of trying to talk and organize because this might be the normal for a little bit. Or shoot Aaron or myself a message down in Portland, and we'll try to make it work out. Since this is, mostly a regional thing, it would be cool to keep it region, but I mean, we're not constrained to that either. Just trying to make it feel like a community thing in whatever way we can. So that's it. So that's the slides. Do you want to give a couple of minutes to let more folks come in? I know we like called out that on the time that we were gonna do AV work for the first 15 minutes or so, and it talks at 6:15. So
Yeah, let's do that. It was our first talk as Evan, right?
no, it's Sean.
Oh, it's Sean. Okay.
Are you good to go? I'm going to be kind of just
Yeah,
manning
no,
the chat.
Cool.
I'm happy to go whenever. If you want to wait until 6:15, you want to go now, I'm game.
Let's mention the Q&A thing. So we have a little questions box. Logan, you want to go into that, or you want me to?
Sure, sure. So we have a lot of people that RSVP'd for this event. If you ask a question and you put in there, if Sean, if you have it open on the other end there, you can kind of see as questions come in. If you want to answer something, you can. Generic CA or nay.
Yeah, no, I'm happy to answer questions as they roll in. Like it's,
okay.
I just wanted, like, my goal was to convince people this stuff is exciting. So
Oh yeah.
whenever people are ready to jump in, I am.
Cool, cool. So what else about the Crowdcast platform? It is like a 2-hour time limit. So at 8 o'clock, Crowdcast will turn this into a recording. It'll turn the carriage into a pumpkin. So the chat will still keep rolling, but the video might stop. So if that happens, we can, we'll figure it out. So that's kind of the platform as a whole. So just, I guess before we get into this, just like, let's try to get closer to 6:15 so that everyone's interested in the talk can get in. My voice and video are out of sync. So one thing that you can do, Arto by wow, nice. Oh yeah, okay. Hi, Meg. So one thing you can do if the video looks weird or something drops out, in the lower left-hand corner, there's a box, and it basically like tries to combine all the streams into one, and that fixes most of the video issues that might pop up. I think right now there's like different video streams, and it can cause issues. It's not WebRTC. There you go.
Yeah,
I don't know. Is there anything I'm like omitting here?
Why don't you introduce yourself?
Oh, that's a good idea.
Speech.
No, I'm Logan. I organize the PDX Go meetup. That's it. What about you?
I'm Aaron. I help Logan out. I like Go. That's pretty much it. I'm really happy to see tons of people here. If you missed the chat, there's like an analytics box that we can see, or at least I can see. We have all over the US. It looks like we've got Berlin, Zurich, a couple different folks in Eastern Europe, Spain, a few places in India, Kathmandu, man, all over Southeast Asia, Australia and New Zealand, and is that Chile, I think? So except for Africa, we have to get some folks from Africa in here, and then we have every continent but Antarctica.
Yeah, how are people finding this from everywhere? Like, I'm curious.
Good question. Yeah, in the chat, how did you find this stream?
Okay.
Reddit. What's Reddit?
Yes, that was mine. Oh, look at
Okay.
that! Now you
Reddit.
get
I see. Okay, Reddit is a good discovery mechanism. That's good to know. That's pretty exciting.
That's super cool. Yeah. So if you know anybody who can't watch this, we're going to share the link for the recording and just pass it around. It's public. Everyone can watch it. It's going to be around forever. And of course, everyone's welcome to watch it. So feel free.
At some point, it might be mandatory to watch it.
This is high quality content here.
This is what people paid for.
everyone gets what they paid for.
Yeah. This is free. Yeah. Please like and subscribe.
For
Yeah,
more
it's just
videos
like
like this.
click the doobly deal, right? Okay,
Oh,
so where's the
100.
place to Reddit? Yeah.
101.
So yeah, I guess we'll just continue shooting the breeze until 6:15. Don't forget to ring that bell.
Smash that like button, and you might see more like this.
Yeah. I wish I had more to plug here. I don't though.
Oh,
Tell a dad joke.
oh, oh,
Oh,
oh! Why can't you hear a pterodactyl use the restroom?
I don't know.
Because the P is silent.
That's definitely a dad joke. That's actually like a kind of funny dad joke. Like all the dad jokes I get are just like not well received. And I think feel like that's the essence of the dad joke.
Yeah.
It has to be negative levels of funny, just because the laughter is the eye roll.
Yeah. But not this one. This one was like underflowed into very.
It was pretty good. Yeah.
Well, do y'all know that I had a bunch of books fall on me today?
No.
It
sucks. Sucks because they only have my shelf to blame.
Oh yeah, this is good stuff. This is going into the library. Let me see here. Definitely going into the rotation of dad jokes. So, Sean, are you working in Go primarily right now?
No. So actually, my day-to-day job, I write C in like C89. I do like embedded software for camera devices. So.
Oh wow.
Yeah, and so like it's all the stuff is open source, so you can look on my GitHub and see like what it's linked to. But yeah, it's basically like getting WebRTC to work for embedded cameras and like robotics and stuff like that. Because like right now there's a C++ implementation of WebRTC that Google purchased, and it like weighs in at like a couple megabytes, and so you can't put it on these very, very small devices. And so I did Pion, and then now I do this job. So like I wrote one WebRTC implementation, then I'm doing this again now. But now I'm getting paid this time.
Oh, that changes things a lot.
Yeah, that made it a little more fun.
That'll get you writing in C.
Yeah. No, I don't know. Like my life is pretty evenly split between Go and C, and I really enjoy it. Like I'll be honest.
Yeah. So does the C stuff like inform how you write Go, or is vice versa? Or is it just kind of two different mindsets?
So my first language is PHP. So everything, I just try to bring the happiness of PHP to other languages. No, it's a funny question. I was actually talking to someone about this. It's like I feel like you think in the first language that you really learned. And so like my first job was like LAMP developer. And so like forever, like I'll like write things. I'll be like, man, I'm like writing this. I was writing it like JavaScript for many, many years, but I feel like now my first class thought is Go, because that's all I've been doing the past couple of years.
That's pretty cool. I mean, there's the K&R C book and the Go programming language, the Donovan and Kernighan book there's some parallels, obviously different eras. Like there's no K&R style to the Go programming language. Go pumped.
No, they did put out like a book, which I haven't got yet, but I forget. Like I think it was like Kernighan was like one of the authors on it, right? Or yeah. So I like that seems like that's the Go Bible, but I haven't read it yet.
You should totally check it out. It's a great book. It's like goes through all the language features at the time. This is like not like a 5 or 6 year old book, but it has kind of like those exercises at the end of each chapter that are very much like the C K&R book. Like, hey, well, I mean, obviously the K&R book didn't do the write a web scraper that gets GitHub issues, but it's a fun book.
Well, the book I'll plug is, I don't know if anyone's into the Wolfenstein 3D Black Book. It's super fun. Basically, it talks about like the Wolfenstein 3D implementation and like how they had to do all these like crazy optimizations to make it work on like an old 386. It's a fantastic book, and I've been like since we'll work from home, I was like leafing through it, like learning all these deep tricks.
That's pretty cool. That's pretty cool.
So yeah,
someone at work shared with me the source for I think it's God of Thunder from like it's a DOS game from the early 90s, and they open source the code on SourceForge, and it is probably not a similar thing. Like that sounds like that's like really intense hardware tricks. This is just like a pretty gnarly C code base to. But your quest, should you choose to accept it, is get this C code base to compile. So I think we kind of like. Is everyone ready for a talk now? Came for the Go talks. Hey, what's up, Ryan? So let's
share my screen.
Yeah, let's do this. I will. I'm gonna hide my video, and we'll start the talk. Feel free to ask questions during the talk. I'm just gonna be kind of hanging in chat. Thanks for doing this, by the way, Sean. Appreciate it.
Yeah, of course. Yeah, so one more. Hopefully, everyone can see my screen and you can hear my audio. Cool. Okay. Great. Well, thank you very much for everyone coming today. It's a lot of fun. I'm excited to share this. It's something I'm super passionate about. So, first off, like, what is Pion? So, Pion is a Go project that we've been working on writing implementations of popular like RTC technologies that people need. And so the first one we did was we wrote a turn server, and then we wrote a WebRTC implementation, and then we realized there's all these like foundational things you need to do. So we had to like do a DTLS implementation and all these hard problems. And first off, I want to say like thank you to everyone that's been involved. Pion is not like a software project that's driven by like a company. Like, it is totally a community-owned thing, and everyone here. They might be working on it on their work time or their personal time, but everyone here has been like, they contribute directly. And if you're interested, we would love to have you. I think that open source is fantastic because you get to build something and you get to see people use it directly. And I think it's also great for your own like personal satisfaction in your career. You get to directly own the things you've worked on and you get to bring them with you everywhere. So first off, everyone, if you're new to WebRTC, like, let's just like take like a quick dive into what it means. And I'm gonna morph this into more like, what does it mean for Gophers, or like for someone that's building like a backend service, or all the kind of problems that we deal with. So WebRTC for most people is a browser API. And what that API gives you is a end-to-end secure connection. So WebRTC, if you're talking to another person via WebRTC, it is always secure. There's some cases where you can run WebRTC through a server and then you have problems. But by design, when you jump into a WebRTC call with another person, the only other person that can see that content is the other peer. And then it supports multiple audio and video tracks. So just like right now, we can share, I can share my desktop, I can share my webcam, and I can talk to multiple people. And then the last big point is the binary data. So WebRTC allows you to do data channels. And these data channels can be lossy, they can be unordered, and you can have multiple ones. And this is super powerful because it kind of frees us from all those constraints of TCP. So like, if you're building a game engine and you want to distribute player state, you don't want to do TCP, because if a packet arrives late, you don't care where the player was 3 seconds ago. You only care about what's happening right now. So since these data channels are running over UDP, you get the latest state. And then you can also go back and have a streaming like TCP-like thing if you want. But this is going to be important later when we talk about all the cool things that like Go developers are building. And to get those kind of things, like, what are all the problems we have to solve? You have to get the connectivity. And it's okay if you don't know the answer to this. I didn't know before I started this project. If me and you are sitting on our home networks, how are our computers able to talk to each other? I have my own private IP inside my network. You have your own private IP. We might have public IPs. Like, how does that all work? How are we able to talk to each other? There's multiple routes we could talk to each other. Like, we could talk to each other via our local network. We could talk to each via the company VPN. Like there's not a single path between you and another computer in the entire world. And then the latency is super important. If you're on a conference call and the latency is more than a second, like you'll just start talking over each other. You'll have all these issues, and that's why it's super important to have that sub-second time from you to the other person. And then ease of use. Like this is an API that shouldn't require you to understand anything about these deep like audio video problems. And then so let's talk about like how it's solving these problems. So this is the first one. Is let's imagine that you're trying to talk to someone else, and on the left that's you and your computers. You have your private IP, your 192, and on this other side you have a bunch of computers with their private IPs. How do you talk to each other? Like, there's no way you can. But what WebRTC does is this really cool thing called NAT traversal. And what NAT traversal does is if you send out a packet to a public server, that public server will then respond back to you on the same port. And what you've done is you've punched a temporary hole in your NAT, or what most people see as their public IP, and now anyone can get to you via that hole. So that's what that black circle is there. So I've gone out and I've punched a hole, and so now anyone that wants to talk to me can now send packets through that. You're probably familiar, like people will say like, oh, you need to port forward so you can access a computer on the local host. Well, this is basically automatic port forwarding. So you don't have to worry about doing it manually. Like there's no like going into your router and saying like if port 5000 maps to this internal computer, this happens on the fly and you get a temporary hole that anyone can go into. And then you have the next problem, which, okay, so we can establish these holes, but what if we don't even speak the same language? On the left is a IPv4, the left is IPv6. WebRTC has a solution for that, and this requires you to run on a remote host a kind of relay server where you can send data in and it'll translate it to the other language. So you send in IPv4 and I'll send out IPv6. So there are some cases where you can't do peer-to-peer communication, and this is how you get around that by running a server in the cloud that does these relay communications. And there's no hard numbers on like what the success rate is. I've heard like between 10 and 15% of all WebRTC communication happens via the relay. But like it's definitely something you should run, but you can still do peer-to-peer most of the time. And then this is where WebRTC really gets exciting. So let's say you're on your phone and you're watching a video, and then you walk outside. You probably notice that video starts to stutter. You need to refresh the page. TCP, like unless you have multipath, like it goes one route, and that's how it works, and you're stuck with that. But with WebRTC and the way it works by pathfinding, that it will actually circumvent around networks that are falling apart. So let's say I'm on a phone call and I walk outside, that WebRTC will use this thing called ice renominations, and it'll hang up the communication that's happening that was going through your Wi-Fi, and now it'll go via cellular. So this brings up like a bunch of super interesting things, like you could have two computers that were trying to talk to each other, and they can move between LTE and Wi-Fi, or they could move between different LTE towers. This resiliency is super important when it comes to doing like, video streaming from robots out in the field. And then the next problem that you have to solve is, let's say you're going to upload a video right now. Like we're uploading a video to Crowdcast. You probably think, okay, I'll measure the speed of my network, and that's the video I'll upload. So I'll test and I'll say, oh, I have 50 megabits per second, 10 gigabytes per second, 150. So 50 megabits per second is how much I can upload, and that makes sense. And that's fine. So you've picked your bit rate, and now you start uploading. Like think if you're uploading to Twitch. But here's the thing, that falls down. Like that isn't true. Like the network isn't stable. Like you're gonna have new people coming on and off your network. Someone's gonna start, watching Netflix in the basement, something's gonna happen. Or let's say someone was watching Netflix in the basement and they turn it off. Like you don't wanna be stuck at the bit rate you chose at the beginning of the call. Like that's a terrible experience. So what WebRTC does is it has congestion control, where the receiver will send back to the sender and say like, hey, thank you for sending me video. You can send me more, or you can send me less. And that if you've ever been on a video call, and you'll notice how like the video is changing from blocky to perfect quality on the fly. This is what's happening, is all the people that are watching your video live are going back and saying like, no, please, like send me these many bits. And here's another really cool one that just happened, is WebRTC, like we were talking about earlier, how you have to know each other's IPs to connect, to do that ICE and to like choose the path and stuff like that. Well, that's not the truth anymore. Like what you can do is you can use this new thing called multicast DNS, where if you know each other's names, you can actually send out a message to your multicast and say like, hey, this is laptop B and this is my IP and who wants to talk directly to me. That's super powerful because you don't need to even worry about configuration ahead of time. Like I could drop a bunch of like little autonomous vehicles inside a network and have them talk to each other via multicast. So there's no like configuration ahead of time. Now all of a sudden you can just have people connecting to each other on the fly and IPs can change. You don't have to worry about anything. So those are all the problems that WebRTC solves. And what we're going to look at next is like how simple the API is and how it kind of just works. So if you went to go use Pion, this is the first thing you would write, is if you've ever done WebRTC in the browser before, you probably remember calling create offer, create answer. And Pion WebRTC works the same exact way. You import the library, you call new peer connection. And that new peer connection, what that is that maintains, that will listen on a bunch of random ports and it will generate something called an offer. And that offer is a list of all the IP addresses that you're accessible on and those ports. And then you'll both exchange your list of IPs and ports with the other side, and then you'll try to find the best path to talk to each other. And that was what we visualized earlier with those ICE renominations, is that both sides, they exchange via these offer and answers the minimum, like the required information to bootstrap the call, and then they're connected. And so that's what we're going through here is first we call new peer connection. Then we create the offer. That offer contains like, these are the codecs I support. These are my IPs and ports. And then you send it off to the other side. So those lines that are commented out is basically like you would do like a post or you would send it via WebSocket to the other side. And then the other side would respond with an answer. And that answer, then you set the remote description and you're done. Like you now have two people that are connected via peer-to-peer and you can do whatever you want from there. And this is let's first talk about like how to send those binary messages to each other. And that's via these data channels. So I've just created a data channel called my fun channel, check for errors. And then when that channel opens, send the message hello world. And that's all you need to do. Then on the other side, if I want to receive that message on that peer connection I created, I would just say like on open, like announce that I got a new channel, and then announce and then print the message as it happens. And then, so one of the nice things about the Pion codebase is that it's portable to almost everywhere. So that code that you ran, like you could do go run all.go star.go and run these two peers against each other and do peer-to-peer, and that'd be great. But on top of that, you could run this code via WASM and run it in your browser. So now I have a code base that works both on my desktop and on my browser. And then thanks to Go, you can also run it in the on mobile and other places like that. And then the other part of WebRTC is the video. So here's an example. On that peer connection object where you call create data channel, you can also call add track. You can add a track, and then here's some example code. I cut out some of the middle part, but it's you read from an IVF file, and then you and then you send the video packet. And then on the other side, you listen for the on track, and then you read those packets. And that's it. Like now inside that part that's commented out, you can just loop those video packets that you've just received and play them back however you want. So let's talk about like what people are building with Pion. I think this is the part that's most exciting. I'm happy to answer any questions about the API or how it's used, but this is the part that I think gets people the most excited. So if you ever had like a small deploy and you started out with a few servers, you probably have a Bastion host, which is that one that's crossed out. But with WebRTC, you don't need to do that at all. Like I can put all of my hosts inside of a firewall, and then WebRTC will establish a temporary hole to do that communication. And I think that would be super powerful for security. because instead of running, your VPN or your SSH server on the public internet, you just sit inside and you have a little WebRTC agent that's running on each one of these servers. And when you want to go in, you punch a temporary hole and get in there. And like that hole punching, I think could save a lot of people on like IP address exhaustion and also just the security of it, not having to deal with, people brute forcing you constantly. Here's a fun one, is that someone built a cloud gaming using WebRTC. So they run a NES, a Game Boy emulator, and all these other classic games on a remote EC2 instance or whatever hosting provider of your choice. And then you use those data channels to send your key presses, and then you send the actual video game state back to your browser. And so not only does this remove like the burden of having to set up things locally, but you could do multiplayer with other people, you can save your game state and all of those cool things. And then like WebRTC, don't even think about it. The fact that WebRTC is supported everywhere is super powerful. So even on my smart TV, I can pull this up and be able to use it because they just ship Chromium in it and it supports WebRTC, and now I can play whatever video game I want. It's basically just an open source version of all of these cloud gaming services that are coming out. And you can go and look at it at cloudretro.io. Another one is RTC Tunnel. So I don't have a great picture to visualize it, but what it does is it allows you to access TCP services from the browser. So what this developer has done is made it so that I can open up a web page and the WebRTC will connect to a server that then is running Redis or SSH or anything else. So all of a sudden now I can do everything inside my browser. You can sit in Vim, you can do whatever you want. All of that is just tunneled to another host. It's basically a remote desktop in your browser. And then Pion is like the project. So everyone's talking, they want to build conference calls, they want to build multimedia. And Pion has came out with a like more higher level thing. So instead of like having to use those pure connection primitives, that you have like a full media server that does all these things. And where the topology gets interesting is that they're all a bunch of little Docker containers. So let's say that you want to run, like a SIP gateway, or you want to do like processing on the media that comes in, like speech to text or something like that. All you have to do is add another Docker container and you can add additional features. So it's super easy to like add new things to the code because we built it in a way that you just plop on a new container to add new operations. So instead of having to modify the existing Go code to do something interesting, you add a new little container, you send off a message to Nats, and then Nats will send the video into you. So I can do any kind of custom thing. Like we want to support people building all these applications that we never intended for. And then also it lets you swap out the UI because the Biz Docker container is just a PWA. And so you can rewrite it and do whatever you want. As long as you satisfy the backend APIs, you can flip in whatever you want at any time. Here's the one that is super interesting is Nico. And what it's doing is it's actually running Firefox on a remote host. So in Chromium, you are then accessing a Firefox running in EC2. And where this gets cool is you can watch YouTube together. So you can check this out right now. It's all open source. Like the latency is good enough that me and someone else can watch a movie and it just works. And it has chat and has everything else. And yeah. So Snowflake is a project by Tor that existed before Pion, but they moved over to Pion after it was released, where they allow you to do censorship circumvention via WebRTC. So since WebRTC is supported in every browser, I can go connect with someone else via WebRTC and then download the web page through them. Like one of the problems with the Tor browser is you have to download it and have to have access to it. But everyone has a browser, and everyone in WebRTC is supported everywhere. So me and you connect to each other via WebRTC, and I say, hey, can you please give me this website that's blocked? And then via data channels, you give it to me. So a lot of like the brokers or the people that are like accessing the web pages for people. It's just a full Go WebRTC implementation that sits on these servers that will go out and act as a relay and fetch websites for people. And you don't have to worry about downloading any software. Since it's up in the browser, it just works. And then Strive is a company that's building with Pion, and they're doing the same thing, where instead of fetching stuff from like over HTTP, like think about it in this way: like if all of these users that are in green wanted to watch a URL, they would have to go to YouTube, they would all download the video, they would all, spend like 15 megabytes of bandwidth doing that. But there's no reason we should download the same video 10 times. So the CDN Edge server, only one person downloads a video, and then it's shared between all the people inside of their work network. So I don't have to pay to download the same video 10 times. I download it once, and then everyone inside my network then quickly shares the video with each other. So you only pay to download a video once, but then everyone inside the Office network gets to watch it. Harmony is a great project. Is you get to have the power of conferencing. It's like one go run, and boom, you have a quick audio server that people can talk to each other. It's also run by someone that might be here today, but it's a super great project to check out. And then this one is totally out of my understanding, but someone shared this is a Tello, so you can control a drone and then watch it via WebRTC in the browser. So they run this process that runs Go on the drone, and then you're able to like script it and do all these things in there. So I can't give you like a deep explanation of how this works. This was totally out of my domain of expertise, but it was a super interesting project that I saw recently. And then the camera case. We have a lot of these like cameras that have come up that are super hard to program for. Like it's hard to find C programmers, and it's even harder to find to write secure C code. This is something I feel pretty passionate about. Is I'm imagined that like all of these people that are doing conference calls, like what if there was a vulnerability in all this WebRTC C++ code? These are like important things that we're talking about, and these are like sensitive conversations, especially now that everyone's staying home, like telehealth and all these personal conversations. So for the ability to put Pion onto this camera, and I feel that like we have this safe, maintainable, secure code that you can just throw it on the camera and watch. And then in the same sense, if you want to go and have a conference call with someone, you can just do it via Go in your command line. Someone wrote a implementation of WebRTC that it goes out and it fetches the VP8 and the Opus, and it decodes it and then does that to ASCII. So you're able to have a conference call and just sit in your terminal with someone. And then because it's WebRTC, it works across all these different platforms. So now I can have a conference call with someone that's on Android, that's on iOS, that's in the web. It's a standardized technology. And then Pion needs you. So everyone that's interested, we would love to have you. I think projects like IPFS and Tor, like these are super important projects. And by making Pion better, it's only going to help others. And then on top of that, it's like this WebRTC knowledge is hard to come by. Like this is I think a once in a lifetime opportunity to help a project that's like young and growing, and to learn a bunch about it. And it's just a fun challenge. You don't have to worry about like the deadlines and other stuff like that. Like you get to pick the little part that you're passionate about, and then you get to dive deep into that and solve the problems you care about. So those are all the places that you can find us on github.com/Pion. That's like the overarching big project. And then also we have this in the Gophers Slack, that's just a link. And then our Twitter. So I try to post like fun WebRTC things and stuff like that. So thank you very much, and I'll check out the questions and see if I can answer anything.
Well, that was crazy. I don't even know what to think. That was so cool, Sean. So thank you for that. I think most of the chat is just people saying they're blown away. Where do I sign up? This is wild. This is cool.
Yeah, no, I'm super happy to share.
Yeah. So if you have questions, put them into the Q&A. I see that a lot of people have already. So let's start with the one about Twilio's rooms. It says they're currently using Twilio's rooms, but it's not free. So what Pion project would you recommend to get started running their own turn and stun servers?
So Pion does have its own turn implementation. So if you go to the Pion/turn on GitHub, you can download and deploy a turn and stun server, and it's all statically compiled, so it's easy to do, like any Go project. And then if you want actual rooms, that Pion Ion project is nice because it's basically just like a pre-made conference implementation. So if I have it all set up, so it's just a Docker Compose, and we have pre-built images in Docker Hub. So you can type Docker Compose and you have like a full conferencing room set up that just works out of the box. There's also like a bunch of other great open source projects that if Pion doesn't work for you, I'd also look at Janus WebRTC. I would look at Jitsi. I would look at Media Soup. Like the WebRTC community is pretty deep, and like for any language or any kind of like paradigms that you're interested in, like I think there'll be one out for you. But like jump in the Pion Slack and like feel free to talk about these other projects as well. Like I'm just happy to get more people into the space.
Nice. So there's a bunch of others in there, so I'll let you just go in and answer what you can, what you want.
Yeah, so how does WebRTC handle the equivalent of TCP slow start and just like the general congestion control? So WebRTC, since it's all over UDP, like you get to choose what kind of congestion control you want. So like, for example, on the receiver side, I'll like implement, like a 400 millisecond delay. And so, you'll be sending the video packets and they'll be arriving out of order, or there might be some lost. And what WebRTC will do is first it'll do something called max. So if you send me 10 packets, each of those packets have a unique identifier on them. So I can say like, oh, thanks for sending me these. Like you missed packet 7. Can you please resend it? And so it's up to the receiver to decide what kind of like experience do they want to provide to the user. So I can decide like, oh, I don't want any latency. So I can like play the video as soon as it arrives, and you'll see some packet loss and some green and breaking and stuff like that. Or you can choose to like add a bunch of latency and have a perfect video. That's kind of the high level. Is like WebRTC, the congestion control isn't really defined. It's kind of like do whatever you think is best because that depends on what your problem is. Oh, can you talk about the overlap of features between gRPC, NATS.io? Does WebRTC? Yeah, so WebRTC, it has data channels, and basically what it gives you is you get datagrams, and you can put them on a unique like label. So you can have like 10 streams, and they can all run concurrently, and they're all congestion controlled. I can't really speak to like why is it better or worse than gRPC and NATS.io. The part that I think that's super powerful about data channels is they work everywhere. So if I want to send a message between the browser and my backend server, I can with data channels. If I want to talk to Android and iOS, I can because of data channels, and I want to talk to embedded devices because like it's pretty much everywhere. So that's kind of the selling point for me. But I can't really talk about which is better. I think it just depends on what your use case is. It sounds like something like gRPC might be really great because you get all that type safety and you have those schemas defined ahead of time. And I guess you can do the same with data channels, but you just have to do some extra work. Okay, yeah, and I'll share the link to the drone project. And has anyone done something with AR, XR with Pion? So the only thing I've seen is that someone, I forget how they were describing it, but it was like this multiplayer driving game that it would like analyze the audio, and they would do something with that. So I think like AR, XR, it's loosely related with WebRTC. So I do see some like experimentation and like fun in the space because you can, there's this new thing with WebRTC called insertable streams, where you can just get the raw video packets or the raw video buffers and audio buffers and then do like processing and do a bunch of interesting things. But I think it's kind of orthogonal to WebRTC, but you totally can. Oh, which part of the Pion was the most difficult? I think the hardest part was probably the DTLS implementation. I just grabbed a book. I can share the link in the chat, but it was a no starch press book basically on cryptography, and I just kind of sat and leafed through and learned the basics and built from there. But it's something that a bunch of other projects have come to use, and it's embarrassing, like the kind of mistakes that you make. Like at first we didn't have like a dedicated state machine, and so we would like fall into these weird states and break things and stuff like that. Yeah, so I think that covers everything. Oh, so one thing I do want to call out, so I see in the chat, like WebRTC isn't a scalable solution for video conferencing. So WebRTC, it is peer-to-peer, but what you can think about is that there's no reason it can't be peer-to-peer with a server that is sitting in the middle. So let's say you're in a conference call with 10 people. What most people end up doing is they run a WebRTC peer up in the cloud, and then that server then fans out your video. So like technically the browser still thinks you're doing peer-to-peer, but you're uploading your video once, and then that server's uploading it out to everyone else for you. So you only have to do it once. Pretty much everything is WebRTC these days, like Hangouts, Skype. I know that the Zoom, the web client, is WebRTC. Like it kind of has this very special part where it's like it's the only thing that works in the browser. So you're kind of stuck with it, for better or for worse, I guess. And yeah, we're out of time, but thank you very much for the questions and showing up. I love this stuff, and yeah, I'll jump off.
Awesome. Thanks so much, Sean. That was super, 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 super cool. So I think everyone really appreciates it. So see if Logan can get back on. If not, in the meantime, I'm going to invite our next speaker up. Here.
Hi, everyone. How's it going?
Hi, Evan. So I will let you take it away and mute my sound and video.
All right. Hey, everyone. I am Evan Boyle. I'm an engineer at Pulumi. Really excited to talk to everyone tonight about building cloud infrastructure in Go. I'm going to have live demos. So if anyone would like to follow along, can you drop a note in the chat if anyone is set up and ready to go ahead of time? Otherwise, I may accelerate some of the demos. So is anyone planning on following along with their laptops at home? Can you let me know in the chat? Yes. Okay. All right. Good to know. Well, then, I'm going to go ahead and get started. What will you need? We will get to that in just a moment. But if you want to go ahead and get started, let me drop the link in. Okay, link is in the chat right there. This is just the getting started with AWS guide. It requires that you have Go, the Pulumi CLI, which you can install with Brew. There's also binaries that you can download. And it requires the AWS CLI, the Pulumi CLI, and Go. That's it. Okay, with that, I'm gonna go ahead and get started. All right, can I just get a quick confirmation that I can see my slides? Yep, okay, perfect. We'll go ahead and get going then. Once again, I'm Evan. I'm here to talk about modern cloud infrastructure in Go with Pulumi. Thanks so much for having me tonight, Pacific Northwest. Really excited to be here. So I'm doing something a little different. I have some live polls that were set up ahead of time. So if you go to pullev.com/EvanBoyle164, you can vote in real time on these polls. So looks like a couple of people may have gotten a hold of my slides and beat me to the punch. So let's go for it. I want to hear, what's your background? Engineer, DevOps? Are you, a student? You just learning? Leave this here for a moment. All right, we have a developer-heavy audience tonight. Looks like we have some DevOps folks in the room tonight as well. Hi, good to see you. Awesome. Okay. Well, if you all keep this tab open, we're going to have a few more polls throughout the night. But I'm going to go ahead and move on for now. So what we're going to cover today: first, provisioning, treating your infrastructure as cattle, not pets. Second, architecture. These are things that we typically use in Go and other programming languages. Using abstraction and encapsulation where appropriate to share our best practices. Not repeating ourselves needlessly, but sharing those best practices across teams. And the third thing we're going to do is test. So look at unit and integration testing for our infrastructure, which is something that you would be surprised to hear is not entirely common. So if you want to get started, there are two things to do. So I pasted that link in the chat. If you want to follow along, Pulumi getting started for AWS, and then also cloning this repo, Pulumi examples, into your Go path. If you do that, you should be good to go. I'll just leave this here for just a second. I'm gonna have these steps up in another moment here. So another poll I want to hear: where are all of you in your cloud journey? Are you total cloud beginners? Are you just getting started? Maybe you're actually managing services in production. Excellent, healthy mix, but it looks like we have a lot of veterans here as well. Very cool. Well, hey, if you want to drop a note in the chat, I'm curious. For those of you managing services in production, I'd like to hear, how are you provisioning your infrastructure today? Okay, so you want to go to the cloud, get it? I got more where that comes from. How do you get there? Multifaceted, many different paths you can take. It's super confusing. You could create a VM in 7 easy steps using the AWS console, or perhaps the CLI, maybe the SDK, or you could write a CloudFormation template, or Terraform, or Chef, or Puppet, or Ansible. Wow. The choice is overwhelming. Yeah, seriously. So let's just take a step back for a moment, right? What do we want out of our cloud development process? We want maintainable and correct systems first and foremost, a familiar tool chain that we can use with the whole team, because software isn't built in isolation after all. We got to work with other people and whatnot, right? Confidence making changes, and then the ability to iterate in an isolated development environment, right? And I say, are these goals really different from traditional, desktop development? So yeah, why not rely on the same tool chain that we're used to using everywhere else? Good old Gopher. So now I'd like to start with a simple little demo. So what we're going to do here is create a security group with a public ingress on port 80, look up the latest Linux AMI. We're going to create an EC2 instance using those two properties that we defined. And then we're going to specify a very simple launch script that just starts up a server on port 80 and export that public DNS so it's accessible from outside of the deployment by other programs. I'm going to post instructions for how to get started, but I'm going to walk through this in my terminal real quick. Okay, so can I get a thumbs up, thumbs down? If this isn't readable, can someone who has audio access just chime in here? So what I'm going to do right now is clone the examples repo. So this is Pulumi examples.
Hey, Evan, would you mind doing like one tick bigger than what you got?
How's that?
Cool. I think that should be good.
Okay, perfect. So I've cloned into the Pulumi examples repo here. And so now I'm going to cd into examples, AWS Go web server. Okay. And first thing that we're going to need to do is initialize a new stack. This is kind of like a container for all of our resources, like a ephemeral developer environment, if you will. So PNW Go is what I'm going to call mine. All right, and then I'm going to set a little bit of configuration. I'm here on the West Coast in Seattle, so I'm going to set some config for the AWS region, and I want to deploy in US West 2. Whoop. Pulumi config set AWS region. Perfect, okay. And then I'm going to run Pulumi up -- yes. And while this gets going, I'm going to go ahead and pull up these instructions real quick. And don't worry, we're going to look at the code here shortly. Okay, so this is the time to grab your computer, and here are the instructions for any of you who'd like to follow along at home. So go ahead and make sure you create that github.com/Pulumi path, cd into it, and then you're going to clone that examples repo, cd into the AWS Go web server directory, run Pulumi stack in it to create that ephemeral environment. And then we're going to set a config value for which region we'd like to deploy our resources into. It's US East 1, US West 2, whatever you want to do, and then run this command Pulumi up. So I'll leave this here for just a second for those of you following along. And you can see here that we have created a stack, which is that container that holds all of our resources. We've created a security group and an EC2 instance. And down here we have some outputs. So we have a public host name and a public IP. So let's go ahead and try and curl this, see what we get. Oh, great, we get a hello world. So let's go ahead and look at this code real quick. All right, so we have this pulumi.run. Mostly looks like any other main file that you would see, but we have this pulumi.run, which injects a context that we can use. It has some helpful utility functions, some Pulumi helpers, things like that. And first thing we're going to do is define the security group. And that security group just has an ingress that defines TCP traffic from port 80 to port 80 and defines a CIDR block. From there, we define our AMI, and we use this wildcard expression to look up what is the latest Amazon Linux AMI. Last thing we do, call ec2.newInstance to create our instance specifying the security group IDs that we found before and the AMI that we looked up before. And then here our very sophisticated web server. It's just a bash script that echoes hello world into an index.html file and then runs a simple Python server. And you can see at the end here, this is where we exported those values that you saw in the output, the public IP address and the public host name, both that are outputs available on this server that we created. So another really cool thing about this is Pulumi has output commands, stack outputs that allow you to compose into other tools. So instead of just copying and pasting that value, we can do Pulumi stack output, and the value of that was public host name. Oh, a little bit of a typo there, but if I get that right, beautiful, hello world. Awesome, so let's break it down again. This is the the set of Go bindings for the Pulumi core Pulumi project, and just this context function that gives us a container for which we can create cloud resources inside of. Here we import the AWS bindings, create our security group, redirecting traffic 8080, and create a CIDR block. Then we look up our AMI, use those two values, pass them into the EC2 instance, specify that user data, export those values so they're able to be accessed programmatically by other programs or by just us as operators using the CLI. And then finally, we can manipulate those outputs and see the response from our web server. Okay, I'm going to stop here real quick for any questions. I'm going to switch over to the chat. Let's see. You can't skate bash ever. Yeah, that's a great point. And actually, you can kind of escape it. We'll get to that a little bit later. Can you talk on how to maintain a remote state? Let's hold off on that one for okay. Questions tab. Let's see. Since Pulumi is all code using standard languages, is there a way to do TDD unit tests? So glad you asked. We're going to get to that later in the talk, but yes, there is absolutely a way to do test-driven development and unit tests. I'm going to defer the question on remote state. By remote state, do you mean how do you? Well, that's a little bit of a good segue into the next question. So I'm gonna defer that one for now. Okay, so this is perfect time for a pop quiz. Hope everyone's ready. Did you bring your pencils? All right, so if you can open up the chat again. Oh, looks like someone already came in here and voted, but is Pulumi imperative or is it a declarative desired state configuration? I'd like to hear what everyone thinks there. All right, a little bit of a mix, but it seems like okay. Well, I don't know. What's the answer going to be? Trick question. Why not both, right? So let's go ahead and look at this. If we run Pulumi stack export -- file stack.json. So and then let's go ahead and look at this output.json file. And let's look here. So what do we have? We have right here, this is our Go web server EC2 instance, okay? And inside of here, you can see we have inputs. So what are some of the inputs that we passed in? Here is that AMI ID that we looked up dynamically. Here's the instance size. There's all sorts of other properties, such as the user data. Here's our sophisticated web server. And you can see on the other side, we have all of these files that were eventually resolved. So what zone it's in, information about public, private IP addresses, etc. So going back to the question at hand here, you write imperative code, Pulumi executes it, produces a declarative state file that we already looked at, right? And drives to that desired state. So the answer to the pop quiz is Pulumi is both. It's both an interface for writing imperative code that's executed to produce desired state, and then the backend engine, which drives that desired state to completion. So I'm going to go ahead and switch back to the chat real quick and see, do we have any questions here? I do agree. It's imperative that you eat more fruit to stay healthy. Yes, thank you very much. All right. If there aren't any other questions, please feel free to drop them in the chat if you have them. I'm going to go ahead and move on. All right, so Pulumi allows you to create reproducible, isolated instances of your project. We call these stacks. So each developer can spin up and tear down environments as will. If your environment gets forked, you can just take it out behind the shed and put it to rest and spin up a new one. So that life cycle here looks like Pulumi stack init to create a new environment, Pulumi up to populate it with cloud resources according to the state that you've defined, Pulumi destroy, which cleans up all of your resources because we don't want to pay for that, right? And then Pulumi stack RM to delete that container and delete the history associated with it. So we're going to go through just a very small amount of Pulumi 101 here real quick. You may notice that we redefined some types here. We had that strange Pulumi.int and Pulumi.string for port 80 and for TCP. Like, why? Why would we do this? Why? Well, deploying to the cloud is fundamentally asynchronous, right? Some values we know at runtime, like we're building a web server, we always want to expose port 80, but others only resolve at runtime. Like, what is that public IP address of our EC2 instance? If you know that ahead of time, I may have a business proposition for you. But so Pulumi has what's called inputs and outputs. So talk very lightly about types here. So if we just consider T to be some type, so T could be a string, T could be an int, it could be an array, it could be a complex struct. An output is an asynchronous object that promises to resolve with a value of type T. So if you've ever used JavaScript before, this is very similar to promises. So we create that EC2 instance and every member of the results. So you may remember we looked at that state file. So everything here in the outputs, this AMI, this ARN, all of these are asynchronous values that promise to eventually resolve, but are not immediately available when that code runs. So an input of T is either an output of T, so is either that eventual value or a promptly available concrete instance of that type. So this could be, an async value, that security group ID that doesn't exist yet, or it could be that port that we've already defined, port 80. So when creating cloud resources, all these input arguments must be input of T to accommodate both prompt and async values. So everything feeding into a resource when you create it in Pulumi is an input, and everything that comes out is an output. And so, why all these custom types? Everything comes back full circle, right? This goes back to our lovely generic questions that we talked about at the beginning of the meetup tonight. So Pulumi uses union types in other languages to represent this. So an input is either a T or an output of T. And Go doesn't have generics for now, at least. So we must define our own custom types. And those custom types use a combination of strong typing, interface, and then reflection under the hood for runtime checking to allow us to represent this union type, this generic union type, while still offering that strongly typed API. So it's a little strange, something to wrap your head around, but is what it is. Let's see if there's any questions on that. Oh yeah, static IP. All right, that's your business proposition for me. I may be out of a sum of money. I spoke too soon. All right. Any other questions? Okay, looks like a few have popped up in the meantime. How is your feature parity with the likes of Terraform and CloudFormation? How long does it take between new services launched and Pulumi can support it? So Pulumi actually uses some of the Terraform providers under the hood. So we use the Terraform AWS provider, for instance. So those are up to date just as fast as the AWS providers are, or the Terraform providers are. We don't actually, just to be clear, we don't actually produce Terraform or anything like that. We just use we are compatible with some of the underlying provider mechanisms. And for others, like we have some native providers that we've written ourselves, like we have a fully modeled the Kubernetes open API spec. So we code generate a bunch of SDKs based off of the Kubernetes open API spec. So when 0.18 came out 2 weeks ago, we actually had our support launched before the PR was merged for Kubernetes 0.18. So very, very fast because a lot of this stuff is fully automated. Let's see. Try to stack RM, but forget to destroy. Would you be able to delete the stuff you created? You can't, unless you do a forced deletion, you can't delete a stack that still has resources inside of it. So you will be warned. Okay, so where is history for stack stored? This is another good one. So by default, state is managed in the Pulumi SaaS, which is free for like open source and individuals. There are like obviously paid plans for like enterprises and whatnot, but there's a S3 state backend, there's GCP, there's local file backend. So you can manage that state yourself or in a variety of cloud providers, or you can manage it in the Pulumi SaaS and see that full history. You do not need to use Pulumi.com to be able to use Pulumi. Okay. Let's see, in case of collaboration with multi-dev, how to maintain remote states. So yeah, this is where something like we have a SaaS or we have like an on-prem hosted state management solution that you can use. And if you're talking about like collaboration with multiple developers, you're talking about locking and concurrent updates and things like that. It handles all that stuff. Very cool. Okay, I'm gonna go ahead and continue on. Manipulating outputs. Okay, so we write these programs, we have these values that can either be promptly available or asynchronous. Like you can't just add two promises together or concatenate two promises. Like it just doesn't work like that. Anyone who's done this async programming knows. So we have to have some way to be able to manipulate these values. Normally we just use sprintf, we just add this thing together, we just set that value of the struct. It's not that straightforward when you're dealing with the cloud and this fundamentally asynchronous programming. So we have what's called apply, which allows us to specify a callback function that manipulates the underlying value when it becomes eventually available. And that's going to return a new output, and that new output can be propagated into other cloud resources that you may want to create. For instance, you could take a bunch of URL components, and when they're all available, maybe the server, the protocol, the port that gets assigned, maybe some network information that's determined at runtime. You can apply all of these values together and then return a URL that can be used as an input into another cloud resource that you're creating. So this looks like this. So we have our VPC and we want to take that output property, that DNS name. We know it's not available right now, but we know it'll be eventually available. So we can attach this apply string callback on there that waits for that value to be eventually available and then splats on an HTTPS at the beginning. And then now we have this URL value, which is now a new output, a new eventually available value. So what if we want to do that coordination that I talked about earlier, like, waiting for maybe a database and a SQL server or something like that, and then creating a connection string. So we can use Pulumi.all, very similar to promise.all if you're familiar with JavaScript promises, to await these two values, the SQL server and the database, wait for those two name values to be available, and then we call apply over an array of those values, do a little bit of string manipulation, and then return them back. And once again, connection string is a new asynchronous value. It is an output, and that output can be used to pass into other cloud resources. All right, and we have, since this is Go, we try to, when we're building this SDK, we try to be idiomatic and, try to do what we can to smooth over some of these idiosyncrasies. So we do have a Pulumi.sprintf, which basically under the hood combines apply and all in order to use something like you would be used to with normal sprintf. But URL, once again, is an asynchronous value, so something to be aware of. Any questions here? Let's go ahead and take a look at the chat. Yeah, Pulumi's tools are open source. That is not something that I mentioned, but yeah, something to definitely be aware of. Pulumi's open source completely. You can go and look at the Pulumi providers, all of our cloud providers and SDKs. All the work that I do is open source, which is amazing. Let's go ahead and look and see if there are any new questions. Pulumi do auto deploys. If you push to master, will it automatically do a deploy for you? So yeah, we are not a CI/CD operator. Like there's lots of CI/CD providers in the space, and we integrate with most all of them. So we have like orbs for Circle CI that are pre-built that you can just grab and go if you want. Let's see. Are you able to talk about how folks are currently using Pulumi? Oh man, that is a super long conversation. Everything from people building SaaS, people migrating 50,000 line Terraform legacy deployments that they have into something that's more componentized, more manageable. We have people who are doing lots of Kubernetes, lots of serverless workloads. We call ourselves modern infrastructure as code because we have put a great deal of emphasis on support for things like Lambda, building Docker images as a part of your deployment, pushing those up to registries. We have a Docker package that will actually build your app for you. You can specify like build parameters, so you can build your Docker image and then deploy it to ECS. A lot of Kubernetes stuff. A lot of people who are doing both the deployment of their underlying like infrastructure, like defining VPCs, deploying EKS clusters or GKE clusters, and then also in the same program defining their Kubernetes resources, which is really, really cool. All right. So architecture as code. We want to compose our infrastructure into useful units. Extract these into functions, publish libraries, share these with the team. And we acknowledge that, like, when doing something like a VPC configuration, not all of us are Sean with extensive experience doing RTC and extensive network understanding. Like maybe you want to abstract some of that stuff away from your team for security purposes. You have best practices you want to follow. So let's take a look at our example that we wrote previously. So we've pulled this all into a create infrastructure function that returns this infrastructure struct that just has the raw group and the server exposed, right? But all of the logic is now hidden and nothing's configurable anymore. One thing to note down here is that in that AMI, we're now using a hard-coded custom AMI. So we have this AMI value for the new EC2 instance, and we're not specifying user data anymore. So our Hello World web server is no longer using that user data. It's no longer configurable. It's the stamped and approved image produced by our company, right? And so the main code here looks very similar. It's just a lot shorter. We run that create infrastructure function, and then we export the public IP and the host name just like before, right? But it's a simpler interface for maybe those who want to run a web server but don't want to be exposed to all the details of network configuration and which AMI to pick, yada, yada. And so these improvements are shared, right? Like I said, we don't have to worry about the network configuration. We can encapsulate and expose the appropriate level of detail. We can enforce policy, like, make sure that everyone has the appropriate tags on all of our deployments that allows us to build like operational tooling, further automation. Stop real quickly for questions here, just in case. Let's see. I agree that it is super cool that you can define K8 stuff right next to other stuff. Yep, and we see a lot of people who do things like K8s for their compute and stateless workloads, but they take advantage of like data solutions in AWS and Azure. So maybe they have SQL in Aurora, or they want to do some log analytics in GCP, some machine learning in GCP. It makes it really easy to do that. How do you handle the version of the Pulumi API? So we release minor versions every week or so, and we try very hard to maintain a semantic versioning. Basically, that's what we try to follow. So we are actually about to next week go from 1.0 to 2.0, which is really, really exciting. So there are a few minor breaking changes. Nothing for Go that's going to be a break, because Go is actually going into preview, or going out of preview and into GA. So you'll get a full contract, which is really exciting. All right. So testing, yeah, finally getting to the stuff that everyone's excited about, right? Love writing tests. So, you know, since we're in the ecosystem, can we use Go Test? Can we use, you know, our favorite mocking tools, Go Cover, like all the tools that already exist? We don't need to reinvent the wheel, right? Can we do this? Hopefully, maybe. Yes, yes, of course we can do this, right? It's the whole, one of the big benefits of using a real programming language is that you can take advantage of everything that exists in that ecosystem. And so let's go ahead and write a unit test against our create infrastructure function, right? So we want to verify that that service has that tag so we can build that operational tooling, right? That no one is specifying that user data. We you know, pretty sure that they can't because we wrote that function signature that takes in no parameters. But we want to just be extra super careful. And then we want to check that SSH is disabled because it'd be really bad for someone to be able to log onto a server and you know, take our user data. So this is another good time to go ahead and grab your computer. I'm going to switch over to the terminal and I will post instructions in just a second. All right, I'm going to go ahead and do a Pulumi stack destroy -- yes. Or sorry, not Pulumi, Pulumi destroy -- yes. All right. And while that runs in the background, this is just to clean up my old AWS Go web server resources. I don't want to pay for those. So I'm going to open up a new tab and I'm going to cd back into testing unit Go. Okay. And we can go ahead and open this up and look at our main. This is our create infrastructure function that we had, right? And then look at our main test. We have some mocks that are not super exciting. And then we're going to step through this testing code here. It's runs inside of a standard Pulumi run. This variant returns an error so that we can check and make sure. And essentially, we're going to use pulumi.all and apply to await for these asynchronous values that we've mocked out. And then inside of those apply callbacks, we're going to do some assertions and use wait groups to coordinate everything. So we have a wait group of 3, and then we're running 3 assertions. And we, you know, looks very much so like a standard unit test. Test infrastructure takes in a star testing T, and then we can run that test from here. But I'm just going to go ahead and go back to my console and just run go test. And so while that gets started, I'm going to put those instructions up for anyone who wants to do this. So yeah, Pulumi examples, testing unit Go. And then all you got to do, go test. And you can deploy this example if you like. It may require you setting some additional configuration, but yeah, it's there. You can check it out and try it if you want. Okay, cool. And you can see, hey, half a second and our unit test is executed. So let's dive in a little bit and see. We got a passing unit test. That's awesome. Let's check out, what does this thing actually do? That's why we're here, right? All right, so like I said, we have this pulumi.run error. This one's a little different because we specify some mocks as an additional parameter, so pulumi.withMocks, and pass in those mocks that we defined above. And we're using a wait group to coordinate these 3 sort of asynchronous tests that we're going to run. And so our first test, we want to test if this service has tags, right? So we're passing in that server URN, that unique address that we can use to identify it. Then we're passing in the tags from that server. Just passing in the URN here so that we can you know, add a little bit of verbose logging if perhaps something fails and we have a bunch of resources in our stack. So wait for those available values to become available. Call this apply callback. And then make sure that that tag, that name tag, exists inside of the tags collection that gets passed in. And you do see here that because of the nature of like generics in Go, when we do this all that gets called into this apply T, we do have to deal with interface. This is a result of providing something that is, you know, works with these union of input types, this T and then output of T, in a language like Go that does not support generics. And it sounds like many of you hope it will never support generics. So. And then we have, you know, this other test that just tests to make sure that user data is empty, basically. So want to make sure that that user data value is nil, that no one's clobbering that AMI that we worked so hard to pre-build with our blessed web server image on it, right? And then this one's a little bit more involved, but similarly passing in that URN and that ingress and awaiting those values. Then once they become available, we're gonna loop through everything in the ingress that we have and just have a little flag value to see if something's open in the internet. And if we're on that open CIDR block, we're gonna break out and fail. But this shouldn't look too foreign. This is very, other than the all and the apply, this is probably very similar to unit tests that you're used to writing inside of Go. So these are unit tests. We aren't verifying the functionality of a particular cloud service or the behavior of your infrastructure. You can't make HTTP queries to cloud resources that don't exist. They're mocked out. These tests are only as good as the mocks that you write. But you can verify quite easily things like control flow, logic, propagation of expected values and configuration, this behavior of your code in isolation of the cloud. So if I call this method, how many Lambda functions are going to be created, or how many EC2 instances are going to be created? And as you said, half a second. This is blazing fast. Doesn't require that CLI binary to be on your machine. And it gives you that sort of tight inter-dev feedback loop that a lot of people really love. I love it. Any questions here? Let's go ahead and stop for a second. All right. Is there a way to make your tests actually try to destroy my infrastructure? Oh, wow. It's so great when people throw you a softball that you're set up to answer in the next slide. How do you handle the version of Pulumi? Okay, we got that. Thanks, Aaron. Yeah. He says he'll take his payment via Venmo. All right. I'm going to go ahead and move on since, Aaron needs to get paid, obviously. Integration testing. Yep, you are right. So we do have ways to do full end-to-end verification of our deployments, spin up our cloud resources in an ephemeral environment, execute some code afterwards that has access to those stack outputs, that has access to those cloud resources, and then tear everything down. Make sure we don't leak those resources in CI or in your local development environment, because we don't want to continue paying for that, right? Cloud is expensive enough as it is. So this is how we can verify the integration of cloud resources. Like when I change that IAM role, did I suddenly lose access somewhere? Did I tighten things down in the proper way? Verify that EDE requests can flow through the system. And then, yeah. So let's go ahead and I'm not actually going to do a code demo for this one because, as we said, deploying cloud resources, spinning them up, executing, waiting, doing retries, and then tearing down the resources doesn't demo quite as well. But this is inside there. I will just go ahead and show you where this code is. So testing-integration. And if you look inside of here, one of the things that's kind of cool, if we do ls program, we're actually using our Go test harness to deploy a TypeScript program here. I hope that I get invited back after showing TypeScript during the Go meetup, but we're actually not going to talk about the TypeScript program at all. Just think it's kind of cool that our test harness does support executing languages in a variety of other, or executing programs in a variety of other languages through Go. We at Pulumi are Go engineers. The whole Pulumi engine, CLI, all the providers, everything is written in Go. It is our favorite language, and something I'm excited to work in every day. But yeah, long story short, if you want to follow along and try this out later, you can go to the testing integration. Cool. So here we have some basic configuration that's defined. Once again, just looks like a regular Go test, right? Takes in a testing object. And so we have this program test options that specifies where is that, where do those files that you want me to do the Pulumi up over, where does that program live on disk? Some other configuration values. And then you remember how we had to specify what region we wanted to deploy our resources to. So you can specify that same config map programmatically through this test harness. And then this extra runtime validation function is what gets executed after your update has completed successfully. So in this case, we're going to look for our stack outputs for our website URL, that public host name that's exposed. And we're going to execute that request with a little wrapper that does some retries. And just once we get that result body, we're going to assert that it has hello Pulumi, which is what we had baked into our web server. Awesome. So, integration testing, this is how we validate the end-to-end flow of our cloud resources like in the wild. This is a much slower process than unit tests. It does provision that full replica of your infrastructure, but it really brings confidence and enables like CI/CD for infrastructure and like moving really quickly. You can't always test every edge case, and every new developers aren't always aware of like all the nuances when starting to poke at infrastructure. So this is what helps you hit that green button, merge your PR, and let it get deployed through your CI/CD system and not have to look back. But yeah, what do we test here? We test, we can do really interesting things like test health checks and alarm configurations. Mentioned before, IAM bugs and things like that. My favorite is the ability to actually simulate deployments, right? So if you have like a secondary environment, you want to do a simulation of updating the stack from one state to the next, you can actually specify multiple steps. So you could specify like different Git hashes of the same Pulumi program. So you could deploy the old program first and then apply an extra step and edit that now does an update. And so you can do things like simulate that prod deployment and measure uptime, like see if you're going to cause a database outage. That's kind of cool. And then finally, this is the ecosystem. So today, Pulumi, all of us Gophers here, we're not really interested in this, but if you did happen to be, we do support TypeScript, Node.js, Python, and then all the .NET languages, integrations with all the source code providers. You can use whatever tools you're using today. So, NPM for JavaScript, you can use VS Code, all the Go plugins that are available there. We have CI/CD integrations. And then available on all the cloud providers. So AWS, Azure, GCP. Like I talked about, we have full modeling of all the Kubernetes resources. We actually have this really cool capability. It's not quite finished yet in Go, but in other languages, you can use our APIs to generate YAML. So if you have some sort of bespoke Kubernetes deployment process and you hate writing YAML, you can write in your language of choice and produce that Kubernetes YAML using strongly typed APIs and this declarative sort of desired state model. Yeah. So just in review, we talked about provisioning. So how do we automate our team setup? How do we automate our application development environments? Treat everything as cattle, not pets. Make sure that we're not incurring too much cost. Automatically clean things up. And then how do we apply architectural best practices, right? Things that we're typically used to in Go, right? Applying that right level of encapsulation for the consumer that we're authoring for. And then last, how do we apply testing best practices, both fast inter-dev loop unit tests and full confidence integration tests that let you move quickly, yeah. And really appreciate everyone taking the time tonight. Really enjoyed being here and talking to you and all of the witty comments. You all are quite a funny group. Lots of ways here for you to learn more about Pulumi. You can hit me up directly on Twitter. Feel free to drop into the Pulumi Slack. I'm Evan on the Pulumi Slack. Would love to hear more from you. If anyone wants to get started on some feature requests, we have a list of issues that are good getting started in Pulumi. So always looking for new contributors and help from the community. So, all right.
Evan, thank you so much for presenting. Is it okay if do you want to have a couple more? Yeah.
No, it's all
that guy over there.
That guy.
Okay.
Okay.
How's the Azure provider? Is it Azure provider right now for Pulumi? Do you have one?
We do have an Azure provider. Yeah, it's backed by the Terraform provider, so it's a similar experience. All right. Well, I'm going to go ahead and look see if there are any other new questions on here. Is there a way to leverage a webhook from Prometheus Alert? I am not familiar with Prometheus. Is this a Kubernetes thing? Can someone tell me?
It's like tracing.
Tracing? Okay.
Yeah.
I'm not familiar with Prometheus, unfortunately, so I can't answer that question. Okay, I don't see anything else. So here, I'll just turn my video back on real quick so I can
Cool.
say goodbye to everyone properly. Really enjoyed being here tonight. Y'all are a fun group, so thanks so much for having me.
Yeah, thank you for giving the presentation, showing us Pulumi. Really appreciate you taking the time to do it. It was awesome, and I think that like other meetups have been doing the sign language applause. So yeah, thank you very much. It's a totally different experience when it's not in person. Yeah, this is awesome. So we're gonna try to do this again next month. Yeah, there's no sticker table tonight, unfortunately. But yeah, next month we're gonna try to do this again. If you're interested in giving a talk, like I said, reach out to the folks. Again, thank you to Meg, Vanessa, and Morgan up in Seattle for getting this all set up. Yeah, reach out to them if you're up in Seattle. Reach out to Aaron or myself, or hit up the PDX Golang. What's it called? Twitter. If you want to go talk. Yeah, thank you again. Stay safe, everybody. If you're interested in the JetBrains raffle, yeah, I'm not really sure how we're going to handle that. Just in chat, if you're interested in the JetBrains raffle, I guess just say I'm interested in the JetBrains raffle, and we'll go with that because I know you're here at the end of the meetup. I've got 2 license keys. So I got Conrad. Okay, so this is a lot of people. This is a bit different than writing the name down and putting it in a cup and shaking it and pulling it out.
Should we try? I think we might be able to do this in a question that people can answer, or maybe people can comment on.
There we go. That's way better. As you can see, we're rolling with this.
We're moving at the speed of innovation.
Yeah,
that's the thing, right? Okay, so check out in the questions and answers thing. There's a comment under the one I just put up there.
Yeah, do that, and maybe after this we can raffle off. We've got 2, and we'll have at least another license next month as well. So this is
all right. So
what's an orange? It's a fruit.
No, she asked. Vanessa asked, "Do I have a what?
Orange.
A hardware orange."
If anyone would like to join me, I'm gonna get happy hour started. I'm gonna go grab a beer. I'll be right back.
Okay. Also, the stream will end in 20 minutes. 23. So are we getting responses in the poll? Is it a poll or a question?
We have let's see. That's at least 10 people in the question.
Sweet.
Vanessa, I don't think I do, but I don't think I do have a hardware RNG. I would. What is that? Because I want one now. I don't know what that is.
I have dice somewhere downstairs. That's hardware RNG.
Nice.
Velvet Tiger. Is that a Seattle brewery?
I don't know.
A D20. Um,
I can do I can throw my gopher heads and tails. We can do that.
do that 10 times.
Yeah.
But we have the ability to get like the list of like how to contact folks, because we can get the list here before it the stream expires, and then we can maybe RNG it afterwards and like contact them through email or something. Google random number. I hear the keys, Aaron. It's still good.
I will admit that this purchase was inspired by a recent Tiger King binge, as I'm sure many have done.
I've heard about the show. I haven't watched it yet. I don't have Netflix, but I've heard it's pretty spectacular. So that's like is it true crime or is it crime?
No spoilers. I'm a
Okay.
strict no spoilers kind of guy.
Okay. It's a comedy. It's a train wreck. Okay. So I've been like very intentional about the media I'm consuming right now. Nothing too dark.
It's it's a little dark, but it's like so crazy you can't make this stuff up.
Okay.
I did want to also one more thing. I mentioned that we're sort of like releasing the next rev, like the 2.0 of Pulumi next week. We actually have an event scheduled. Corey Quinn is going to be co-hosting. I don't know if any of you guys know him, but is hosting live video event. Should be pretty cool. I'm sure he's going to have lots of great snarky things to say. I can post a link to that event if anyone is interested in joining.
Cool. That'd be great. Yeah, Corey Quinn is the Twitter dude. I've listened to, he had like a talk about building your own data center, and it was just really good. It was like a DevOps days talk, and yeah, absolutely not watching the Chernobyl HBO series. Anything that apocalyptic is just nah. That's a pass. That's a no for me. Yeah. Cool. So yeah, there's the Pulumi webinar. So I think Aaron is still he's audioless. He has no sound.
Aaron ran down to the corner store to grab a beer. He'll be right back.
Which, you got to get the full suit, hazmat suit. All right, so maybe we'll just kind of, are we still getting submissions to the JetBrains thing here? Okay, so we got 15 comments. I'm going to do it from 1 to 15, random number. So the first one was 11. I hope this is all displayed in the same order here. So 11. So Ravi Tirala. That's the first one. One based. Sorry. So Ravi gets the first one. I will try to figure out how to contact you. Yeah, we'll do. Okay, we'll sort that out. So we know who gets the first one. I'm going to shuffle the. So 14 is the next one. So who is 12, 13, 14? Anderson. Okay, I will send that to you. And the other one is Anderson Sipe or Sipe. I'm not sure. Okay, cool. Yeah, just I guess maybe the best route is I don't think we can like delete the email from the chat, but message through Meetup with the email address, and I'll get that to you. Are you cool with the email address in the chat? And we'll have a better like solution for this next time. I'm just kind of rolling with it here. Okay, so I'll email Ravi a copy of the JetBrains license, and I'll get Anderson as well. And thank you all again for doing this. Really, it's good to do things that are like kind of normal right now. So I hope that y'all come out next month. We'll try to get that squared away in the next couple weeks or so. Again, thank you all so much. Stay safe, stay indoors. Be nice to everybody. So I'm gonna let the chat keep going here. I'm gonna turn off the screen here because it's weird seeing my face there. So thank you again. Thank you, Evan, for the talk. Thank you, Sean, for the talk. Thank you, Vanessa, Meg, Morgan, Aaron. Super awesome job, y'all. Adios.
They forgot to kick me out. Oh, God.
The floor is yours.
Hey, everyone. Thanks so much again for having me tonight. Everyone has my contact info. I posted those slides and that link to the event on the PNW Go Meetup page. I'm signing off as well. Dinner time for me. Cheers, everybody.